All right, welcome guys to day 13. Doing graphs of events and piecewise functions today. All right. Remember, for graphs from events, major things we're going to talk about are the increases. So an increase that's a straight line is usually indicating a constant increase, okay, as opposed to something that may look like this, which is a gradual increase or an increase in speed over that time. Kind of like an exponential versus a linear. The fact that from B to C here you can see is flat either indicates if it's like a distance from home. In this instance, that there's no distance, he's kind of staying still. Here, this would indicate that he's essentially traveling at a constant rate of speed. And then you can see how from A to B it gets steeper. So we would say that he may have picked up his speed and increased speed during that time. And the speed is indicated essentially by the change of the rate of change, and that which is the slope. So as the slope increases and the line gets steeper, the speed's increasing. Also be careful when we're comparing distance versus speed. So one of them is just how far you're getting away from home versus how fast I'm traveling. So you can see I'm going at a constant rate, that's pretty fast. Then I'm stopping and I'm not going anywhere, I'm standing still. Okay, I then resume moving, not as fast as before. You can tell by the slope, right? The slope is up 3 over 2. This is over 2 up 2. So this is the slope of 1, this is 1.5. And then staying still, increasing speed, staying still. Now I'm actually decreasing my speed. Maybe I'm traveling backwards, okay? One of those things. Where the distance from home, as I'm increasing it, as I get closer to home, I go backwards, my line is going to head back down. That would be a negative slope, so that would indicate. All right, so for 545 actually relates back to this map right here, this graph right here. Which statement best describes what the jogger was doing between the 9 to 12 interval? So 9 is here, 12 is here. You can see there's no speed, so that would indicate she was standing still. So that would be choice 1. All right, we'll come back to these two. During a snowstorm, meter hours tracks the amount of accumulation of snow. For the first 3 hours of storm, the snow fell at a constant rate of 1 inch per hour. The storm then stopped for 2 hours and started again at a constant rate of 1/2 inch per hour for the next 4 hours. All right. Draw and label a graph that models the accumulation of snow over the meteorologist collected. So we would say we want our x-axis to indicate our time, so how much time has passed, and this would indicate the amount of snowfall. Okay, and usually we would say it's like the accumulation, how much there is altogether. All right, I'm going to make this a little bit smaller so I can fit the whole thing on here. All right, and then we just need our time. So for the first 3 hours, right, stop for 2 hours, so that's 5, and start again for 4 hours, that's 9. So essentially I need 9 spaces. So I could theoretically go every other one here. So that's 1, 2, 3, 4, 5. And then I just want to indicate, you don't necessarily need to do the lines on the graph like that. Go a little bit bigger here. But we can indicate with numbers. So this is 0, there's 2, 4, 6, there's 8. We only get to 9, so even if you want to go more, go every 4. That's 2, 4, 6, 8. There's 10, and all the way up to 12. All right, and then the snowfall, if you want to go every other one too, so we can go, this is 2, there's 4, 6, 8. All right, so as we're reading the question, we can see for the first 3 hours, the storm fell at a constant rate of 1 inch per hour. All right, so every hour we gained 1 inch. So go back down. So for the first hour, which is right here, we gained 1 inch. There's 1. The second hour we're at 2 inches. Third hour we're at 3 inches. Oh, I see we got a problem here. Look at, I went by 4 and then by 3 here. So let's see if we can redo this. 2, 1, 1, 2, 3, there's 4, and that's really big. All right, I'm going to fix it. I'll pause it so you don't have to see me doing it. All right, so there's our axis down there, and then we are going to go, now we can finish up with the dots here. So for 3 hours, we went an inch per hour. Okay, then it stayed still for 2 hours. So from 4 to 5, we didn't go at all. And then from the next 2 hours, it went in a half an inch per hour. Okay, so 1/2 inch. So right now we're at 3. So at an hour, it went to 6. We were at 3.5. And then at 7, we went up to, all right, so 3, 5 for the next 4 hours. So then another half inch, and we're right there. And then we can draw our lines here. So we went from 0, 1 inch per hour up to 3, stayed still, and then went up for a half an inch for the next 4 hours. All right. If the snowstorm started at 6 p.m., how much snow would there be by midnight? So this would be another 6 hours to get to midnight. Okay. So if it started at 6 p.m., so 6 p.m. to 12 is 6 hours. So if we go to 6 hours on the map, we can see right here, and this would be in between 3 and 4. So we would have 3.5 inches of snow. All right. On the next guy, driver takes home a business trip, drives at a constant speed of 60 miles per hour for 2 hours. So 60 miles an hour for 2 hours. So after 1 hour, he's gone 60 miles an hour. Go another hour, I go another 60 miles, so I should be at 120 miles. Okay. Gets to flat tires for 30 minutes changing his tire. So 230, he hasn't gone anywhere in terms of distance. So this should be just a straight dot right there. Okay. Resumes driving, now it's 30 miles an hour for 1 hour. So from 2:30 to 3:30, right? She's gone 30 miles an hour. So after an hour, I should have traveled 30 miles. So if this is 120, 130 would get me to 150. Okay. So if each of these dots is essentially 60, okay, we want to go up for for 1 hour, we're going to end up 30 miles ahead. So we should be right here. So this is traveling at 60 miles an hour. You can see it's a steep line. We go flat, we don't move at all. And then this line is not as steep as before. This is where we were. Now we're traveling at half that speed. And we're right there. Okay? That's what the graph should look like. All right, graphing piecewise functions. For these functions, they're going to give us a domain here. Okay? And then, they're going to give us the functions, and then they're actually going to tell us what the domain is that we're graphing these under, meaning in between what x values would I then be providing that graph. When we graph this, we want to make sure we find where the function is changing, which means I'm looking at these numbers, -1, okay? I'm looking at the number 1 here. Mind me while I get rid of the stuff, okay? So I'm looking at these numbers, right? These critical values where these points are, okay? And I can see they happen at 1 and -1. So what I want to do is I want to look and see, all right, at negative, if I plug in -1, I'm going to have to use this function. And if I do that, when the point -1 is given, the y value is -1 plus 2, or 1. So I know that I can go to -1, 1 and put a point, and it's going to be right there. And then I'm going to evaluate it at 1, okay, because it's the other critical value. And if I plug 1 in, I'm supposed to do 1 squared. So I go here, and then I'm just going to graph my line, okay? And we can do the graph. I'll show you how to pull that up on the calculator. But that's what I want to do is I want to figure out if it's a closed or open circle at that point, okay? And then once I decide the open circle, I can just use the table in the calculator to graph more points. So to graph on the calculator, all right, what we're essentially going to do, and I'll take a look at this loads. I'm just going to pause for you guys. All right, so once you have your calculator open, you're just going to go over here to graph, okay? And then once you're in the graph, you're going to go to the symbols button. It's right next to the number 9 in the book. You press this button, and this option right here is the piecewise function. And so you can see it says how many functions. So it's usually either 2 or 3, okay? And then what you're going to do is, in the first box, is you're going to type in what the function is, so what the equation is, and then the second box is going to be the domain. So for example, say that I want it to be y equals 3, so it's a straight line at 3, and we're going to go from anything that's if x, we'll say x is going to be, we'll say less than 2, okay? So anything less than 2, it's going to go there, and then I'm going to do x plus 4 if it's anything where x is, and then greater than or equal to, I have to hit control equals greater than or equal to 2. And so if I hit enter, you'll see there's my piecewise function. So what I don't know is on the graph, it doesn't show me if this point here is open, it's included, or if this point is the one that's included, if this point is shaded in. So you want to make sure you're careful on which one's an open circle and a closed circle. So like I can tell at the first line, when I hit 2, that this point is an open circle, okay, shading this way, and a closed circle, and then going on in that direction. All right, let's do some of these questions here. So in the function graph below, which graph is related to the event? So you can see what's happening is it's going from here to there. So it's a y equals x squared. And then I'm stopping. There's a hole here, and then it continues on in that direction. So if we were to continue this line that we have here, right, back down this way, where is this essentially going to hit the x-axis, or the y-axis? Because that's essentially my slope. And if you notice, okay, I can actually pick 2 points that are on the line and calculate the slope. So if I remember, rise over run, right, slope is equal to, all right, rise over run. All right. So the rise is going up 1 and then over 2. So I can tell that this has a slope of 1/2. So 1/2. Okay. And then the y-intercept, if I continue it down, because I go down 1 over 1 or down 1 over 2, is actually going to be at 0.5. So b is equal to also 1/2. So I can see like that equation is not going to work. That equation is not going to work. So it's going to be this guy right here. Okay. All right. Also, I know because this is an open circle that there shouldn't be any equal signs for these inequalities there. Okay. All right. 553. When the function is graphed, how would the point be drawn on the graph for an x value of 3? So I know if I plug in 3 on the x-axis, that this function is not going to get used because this isn't strictly a greater than. It has to be an equal to. So if it's equal to, then I am going to use this function. And so if I plug in 3, 5 times 3 is 15. So the point is the x-coordinate is 3, and the y-coordinate is 15. All right. So it's now, if you plug 3 into x squared plus 4, 3 squared plus 4 is 9 plus 4, which is 13. And so there should be an open circle here, okay, but a closed circle at the point 315. So 2 open circles would not make sense. It's 2 closed circles also don't make sense, okay. One's got an open circle at 315 and closed at 313, which is not the case. And the other one is choice 4, which is the one we want. It's closed at 315 and open at 313. All right. Here we're going to do a little bit of graphing. So fewer than 10 pencils, it's $1.75. 10 or more is going to be this. We want to create a graph below. So 1.75x, what we can do, now let's use our calculator here, okay? So I want to do my circles. So I know I have a circle at 0, and it's a closed circle, okay? There's also a closed circle at 9. So it's a closed circle at 0, okay? Closed circle at 0. Now, I don't even know if it's 0, 0, because I didn't evaluate the function there, okay? If I plug 0 in, 0 times 1.75x is indeed 0, okay? And if I plug 9 into this function, 0.75 times 9, I'm going to grab my calculator, okay? 0.75 times 9 is equal to 15.75. So 15.75 is just below 16. So 9 just below 16. I know I'm going to put another dot. And now it's a straight line between those 2 points. So I could, if I needed to, but I'm just going to connect those 2 points with a line. I could use my calculator, and that's what I was going to recommend earlier, okay, to graph some points on the line, and then I know I'm going to stop there. Okay, now there's a gap between 9 and 10. There's nothing. And at 10, I'm going to use the point 1.25x, okay? And when I plug in 1.25 times 10 is 12.5. So I know at 10 and then 12.5, I'm going to have another dot, okay? So at 10, which is right here, and then we're going to go to 12.5, and I got another dot. All right, so here, if we plug in 1.75 times 0 is equal to 0, and then 1.75 times 9, and that's where we came up with 15.75. All right, so now I know that I'm keeping this, and 1.25x as a fraction, if you really want to, is essentially 5 over 4, okay? So if what I would do, if we were doing this, or we can use your graph, 1.25x, there's this. I go to my table, and then once I get to 9, okay, 10 is 12 and a half. The next nice point is the point 12, 15. So I'm going to plot 12, 15, so 12, 15, okay, and then I can just draw a straight line from there through and up. All right, and that is my equation. Now, I want to remember that this is an inequality. So it does say, notice the first one goes from 0 to 9, so these should have endpoints. The second one is a greater than or equal to, so that should have an arrowhead. All right, and that should be my equation, guys. All right, next page. Table below is the parking period for a street in Albany, the total cost any length of time, including hours parked. For parking up to including 1 hour, it costs $1.25. 3.5 hours would cost 5.75, and so on and so forth. We're going to grab the step function. The step function looks like steps. So it looks like something like this, okay? So all I'm going to do is, and I know that as soon as I park in the lot, no matter how long I stay, up to an hour, it's going to cost $1.25, okay? So what I want to do is kind of think about this in terms of plotting points, okay? As soon as I park in anywhere, it's going to start at $1.25, okay? So if I park for 0, which makes a little bit of sense here, okay? I don't have to pay anything for 0 hours. So there's an open circle, okay? But then as soon as I park for an hour, it goes all the way over, and it costs me $1.25, and I have a closed circle there. All right? As soon as I go beyond 2 hours, go on beyond an hour to 2 hours, so there's an open circle at 2, okay? I have to pay, go beyond an hour, it costs me $2.50. So as soon as I go beyond 1 hour, open circle at an hour, because an hour would actually be $1.25, I pay $2.50 until I get to hour 2, Once I go a minute beyond hour 2, or even a second beyond hour 2, it costs me $4. So open circle at 4. I drag that over until I get to 3. I have to close my circle. Okay. And then once I go a second beyond 3, it's essentially 575. So open circle there. Line over to the next hour. Close circle. 5 or 4. Once again, if I go just beyond a minute or a second over 4 hours, it'll cost me 5 or 775. Okay, so open circle there, all the way across. Until we get to 6, or at least 5. All right. And then once I hit 6 hours, it's going to cost me $10. So 6 hours itself, and from hour 5 on to 6, and then I close my circle. Okay. All right. This should be an open circle all the way over to there. And closed. Should be a little bit higher, actually. A little tougher to do here with a stylus. But you get the idea. So 775. Fill it in, open circle, going across, and then fill it in. All right, so there's my step function. That's it for this sheet, guys. We'll see you tomorrow.